annotator. Okay, so here we go. Linear inequality is basically an equality with two variables. Okay, so basically you have a line, and the solution to the linear inequality is going to be all points that satisfy it, meaning all coordinates, pairs of x and y, that if you substitute them into the inequality, you get a true statement. Now, there will typically be an infinite number of points because there's a whole lot of points that are on one side of the line, in fact, an infinite number of them. Okay, so this first one is an example of a classic linear inequality, y greater than or equal to negative 4x minus 5. Solution set always divides the coordinate plane into two regions. And just like I said, one of the regions, the solution, is the set of all points that satisfy the inequality. And those coordinates make a true statement when substituted into the inequality for x and y. The boundary line formed by changing the inequality into an equation. Okay, the boundary line is part of the solution with greater than or equal to or less than or equal to inequalities, and is drawn as a solid line. If it's not part of the solution set, you may have a greater than symbol or less than symbol, and it's drawn as a either dotted or dashed line to indicate that. Okay, so how do you graph linear inequality? Well, you first graph the boundary line. Sometimes some people call it the border line. And you either make it a dashed line or a dotted line. I mean, a dashed or a solid line. Then you decide which side to shade. So if you have, here's a trick. If you have the line in slope-intercept form, then, or the boundary line, the inequality in slope-intercept form, then the less than sign indicates that you're going to shade the side that is kind of more on the downside. Whereas a greater than indicates that you're going to shade a side that's more on the upside. So let's see how that works out. Okay, my first one here, excuse me, y is less than or equal to 3/5 x plus 5. I go to 5. I'm going to graph the boundary line. I'm going to go negative 3/5 is going to be down 1, 2, 3, and to the left 5. 1, 2, 3, 4, 5. So that's the same as 3/5, but I was going to go off the graph. So I did the reverse, and I made both of them negative and got a point in the other direction. Okay, this is less than or equal to, so we're going to get a solid. Oops, that's not even close. All right, and then I have a less than or equal to symbol. And I have my equation in slope-intercept form. That means I'm going to graph this side, the downside. All right, the alternative to kind of that trick is to pick a test point, substitute it in for x and y, and if you get a true statement, you shade the same side as the test point. If you get a false statement, you shade the other side. So if I put 0 and 0 in for x and y, I get 0 is less than or equal to 5. That's true. So that would mean I would shade the same side as the test point, which is the downside. All right, so in order to make this move along, I'm just going to not do every single example because this is Algebra 1. You may not have done this for a while, but you did learn it and possibly went over in Algebra 2 as well, or integrated algebra. All right, so here we go. I'm going to first write this in slope-intercept form. So I have to move the x over to the right and then divide by 4. So when I do that, I get, first of all, I get 4y equals negative x plus 12. I should say greater than negative x plus 12. Oh, yeah. And this brings up a very important point. When you have a linear inequality or a regular inequality with one variable, and you divide by a negative number, you have to reverse the direction of the inequality sign, which I think is going to happen in the next problem. Okay, so now I divide by 4. I get y is greater than negative 1/4 x plus 3. So I go to 3. I go down 1 and to the right 4. This is greater than, so I'm going to be doing a dotted line. Let's see, where can I get my dotted line? There's 1. So let's see how close I can get. Good enough. And then greater than, so I'm going to shade the greater than side. Oops. I can do a better job than my 4-year-olds. There we go. All right, so that would be the solution. This next one I'm just going to do so to show you that um, uh, uh, what happens when you have to divide by -3. So I'm going to do the boundary line. Going to be greater than or equal to negative x minus 15. Divide by -3. So when I divide by a negative number, I'm really have to switch the direction of the inequality sign. So I end up with y equals 1/3 x plus 5. I go to the 5 on the y-axis. That's the 5. And up 1 over 3 is that. Okay, I have less than or equal to, so that means I'm doing a solid line, not a dotted line, a solid one. Right, and then I've less than or equal to. That means I'm going to shade the downside. Not the upside, the downside. Oh, speaking of which, here's a joke. The pessimist says to the optimist, "It can't get any worse." The optimist says, "Sure it can." I just read that yesterday. Something about the downside made me think of that. Okay, so then finally is a system of inequalities. So we may even do a problem with related to finances here, which will involve income maximization given constraints. But for now, we're just going to graph a system of inequalities. So a system is two inequalities, and the solution is the set of values that satisfy all of the inequalities. And it's the section where their shading overlaps. Okay, so I'll just do one of these because I've already been rattling on for 25 minutes. So here we go. Y is less than or equal to -1/2 x plus 3. Okay, I'm going to go to 3 on the y-axis, and then I'm going to go down 1 and to the right 2. All right, I'm going to do a solid line because it's less than or equal to. Then I'm going to shade the downside because it's less than or equal to. And then I'll do the other one, 1/2 x plus 1, up 1 over 2. This is going to be a dotted line because it's less than, not less than or equal to. And it's greater than, so I'm going to shade the upside. And the solution is going to be where the shading overlaps, which is in this region right here. Okay. So I'll just do one more of these and then we'll call it a day for this. You have a nice long weekend, and so I'm not going to see you, and I say see in quotation marks, until Tuesday, I guess. So plenty of time to do this homework. I'm also going to take a poll to see how many people have graph paper or any ability to people who have no ability to make paper copies of things, and I may even try to, I can't promise, but I may even look up some of your addresses and drop off graph paper at your house, because actually might be important in a few things. Haven't decided for sure, but you're gonna have problems being really accurate without graph paper. For the homework, if you don't have graph paper, just do a sketch. All right, just sketch the X and Y axis, do a rough sketch of the line based on where its intercept should be and what its slope is. I realize it may not be perfect, but do a sketch, and then you want to draw a line for the systems. You want to, when you do your shading, if it's just one inequality, you can obviously just shade one side. If it's two inequalities, you want to make it clear where the shading overlaps, because that would be the solution. Okay, so here we go. Y equals negative 1/2 x plus 3. So I go to 3, I go down 1 to the right 2. It's going to be a solid line because I have the less than or equal to. So it's going to be that, and it's going to be the downside. So the downside is going to be there. And now I have y is greater than 1/2 x plus 1. So, so go to 1, up 1 over 2. This is going to be dotted, a dashed line, or a dotted line. So, and then that's going to be the upside because it's greater than. And let's see if yellow and blue really do make green. Well, sort of. I guess that is a light green. It definitely does. Okay, so that means the solution is right there. That's the solution. Set. Okay, that's it. Hopefully that'll be enough for you to complete this homework. And remember, you should turn it in. I am grading it for completion for this marking period. It's all the more important now that you guys are seniors and only one marking period away from graduating. You need to make sure you're doing something. You're already getting a break because of not even have to going to school. So really need to be doing the homework. And I hope to see more of you in the Google Meet. I had none today, kind of sad. You know, please join. All right.